We are Team Asmer Software Solutions. We're going to go over our team, our project overview, our target increment goals, along with what we've implemented for our dream, updates from the minimal increment, the demo, addressing risks and lessons learned, deliverables, and our project timeline. Our team is Alec Wayne, our software quality analyst, Matthew Hayashi, our project manager, Rebecca Wilson, our testing programming lead, and Robert San, our lead configuration manager and architect. For our target increment goals, we wanted to ensure all edge cases were thoroughly tested. We also updated the GUI to make sure it was more aesthetically pleasing. Our dream goals included having an interactive game wheel and making the game board questions easily updated for our customer. For our target increment achievements, we were able to update the GUI, which included colors for better appearance and updates to our fonts. We also finished our rigorous testing plan, which went through any potential edge cases. We ensured there was no major issues in our code, and we updated code for good coding practices. Our dream increment achievements included creating a functional wheel and updating the questions easier for our customer. The introduced features included the wheel, which is now interactive and coordinated well with gameplay. Our game board questions are also easily updated now as well. We have CSVs within our folder, which the customer can easily change. These are updated and loaded as soon as you load the game. From our minimal increment to our target increment, we've made great strides in making the gameplay better. You can see here we have our updated wheel. The fonts all look much better, and our coloring scheme is more aesthetically pleasing as well. We're very happy with our updates, and we've succeeded in doing some of our dream increments as well.
All right, so this is ASMR's target/dream increment demo. This is the start screen. It's a new feature. The main purpose of this screen is to add players. So let's do that. We click add player and enter a name. You see we display the names here for convenience. So let's add 4 players. You may not remember, in our past increments, we only dealt with 3. Since the skeletal increment, our code base could support a different number of players. Even when we introduced the GUI, it could handle this. We just never really thought of using a number other than 3 because the actual Wheel of Fortune and Jeopardy both have 3 players. However, we recognized the end user may appreciate the flexibility to use a variable number of players. Flexibility is a property we really tried to either maintain or proactively introduce into our application. I would like to point out that this wheel on this start menu has 12 slices, and the colors gradient equally around the wheel. The board in this situation has 5 categories as opposed to the standard 6. Let's click start and see what happens. Okay, so this format should be quite familiar. We can see the minimal increment GUI influence on this final version. Before we forget, notice that the wheel now has 18 slices, and yet the colors still transition smoothly across the whole wheel. The board now supports 6 categories as the standard Jeopardy board does. So this just to illustrate how our back-end structures and our on-screen components are flexible enough to vary slightly in the number of categories. So the end user isn't strictly forced to use the same specifications as the actual game show. Going over the general GUI, we see that the players are spaced more or less evenly, and the small detail is that we padded the strings the name strings so that longer names and shorter names have a smaller visual discrepancy in terms of the size of box. The spin wheel button is more obvious. It is no longer the default to Kinter button. This is because this is the main screen component that the user will be interacting with, in addition to those prompted text boxes. The board is a more faithful representation of the Jeopardy board with white font for the categories and yellow font for the point values. The whole GUI actually kind of takes the theme of the Jeopardy board, a much more consistent color scheme compared to past front ends. The identity of the Wheel of Fortune game in this combination would be isolated to the wheel. So we did make a pretty distinct effort to color it in. You'll notice the text on this wheel panel is reduced to just the required spins remaining counter, and the selected slice is denoted with this spin pointer or black triangle. One of the most substantial additions to the stream/target increment would be animating the wheel. So let's spin the wheel, and we can see that it has the appearance of spinning. However, in our actual implementation, what's happening is we're generating slices in time, and each increment, the current slice, will take on the color and text of the adjacent slice. So while it looks like the wheel is spinning, the geometry and position of each slice is actually static. With the animation mechanic introduced, let's just run through some of the standard features of the game. One thing that we should be able to notice here is that the actual behavior looks quite the same to the minimal increment. And that's because our minimal increment had the majority of the state behavior defined and tested. Likewise, our skeletal increment had the majority of state transitions defined and tested. Since we invest the time to verify our features before building off of them, when we get to this point, if we can get a random slice into the state machine, we have a certain confidence that the transitions will occur, that the transitions and behaviors will happen as we expect. However, animating this wheel actually did impact how reliably we can provide that random slice. The main issue was the initial implementation of the wheel was time-based. So the random slice was determined by how long the wheel spun. Due to the frame rate and some slight latencies with the drawing geometries, this was actually inconsistent in generating a random slice. Through observations of very few samples, it was clear that some slices were being neglected, not selected as frequently as other slices. Our solution was actually to generate the slice first, so get the resulting wheel slice first, and then spinning the wheel and counting the number of times that slice value was underneath the slice pointer, that black triangle. By doing this, we can actually control more precisely when the wheel stops spinning. This also has the advantage that we can hard code a sequence of slice values that this wheel will visit, similar to our backend. While this feature doesn't really impact the player's experience, it makes testing this graphical wheel much easier. We could test every slice and certain stressing sequences of slices to see if that random slice can be fed into the state machine. Okay, so I ran the game instance down to this position, Just so we can illustrate that transition point. In the minimal increment, we saw that the categories of the board and the point value could be adjusted were populated automatically. But now we can see that this GUI version of the wheel, we can see this take on the new categories when we finish this round. So let's try to do that real quick. Okay, so we recognize the end of round one. If I move this message out of the way, we see the points are doubled and the categories are updated. And now the wheel now has a new set of, the new set of categories. And the point values of the players were maintained in the second round. And before we start playing the second round, and again, kind of skip to the end just to see that behavior, I want to introduce another feature of the dream increment, um, loading in questions, answer selections, correct answers, point values, um, using CSVs. So this is what the CSV that informs the value on the board looks like. One important detail is the name of the file. So qset2, so question set2. The number is to serve as an identifier for the code driver. The idea is to have a collection of these question sets with a number. And if you have a large set, you can reference by the number and have a variety of questions available within a game. So the header for these spreadsheets mirror the fields in the board box. So category, question, option A, option B, option C, the correct answer, and the point value. I want to note that the point value still goes from 100 to 500, even though this is round two. Uh, the calculation of the adjusted point value actually happens in the parser, which has a reference to the round number. And the reason we do it like that is because you don't need to consider which question set will land in which round. It can be a random question set, and the point values will automatically be adjusted to be the appropriate value for that round. Okay, we got round two in a position where it's almost done. So let's try to run this to completion and see that ending behavior. Okay, so apparently I don't know my sports, but we see that when the board ran out of questions, we realized the end of round, even though there are spins remaining, and Adam is the winner with 0 points. So thank you for watching the Dream Increment demo. I guess we'll move on with the presentation.
Addressing risk and lessons learned. Addressing risk. Collaboration tools. The team utilized several collaboration tools throughout the project. These tools allowed us to manage the project deliverables and track progress of those deliverables. The first one was GitLab. GitLab was used to maintain the codebase. This was a necessary tool for maintaining, developing, and organizing the code. The second one was Google Docs. Google Docs was a tool that was used to collaborate on project deliverables. The team could all work on the same deliverables, adding notes, comments, and updating content. Other communication channels were also used to achieve the end software product. The team was in a group text to coordinate team meetings and deliverables, and team members could text each other individually for more specific questions around the deliverables they were working on. The second point, proper cadence for team meetings. The team met every Monday to do a quality check of deliverables that were due on Tuesday. Once this was finished, the following week's deliverables were discussed. This cadence worked very well for our team, as we were able to consistently communicate and get ahead of potential risks. The active communication of the team was crucial to delivering products on time. On to the lessons learned section. Achieve easy wins first while still taking more difficult tasks into consideration. The team was familiar with back-end development and felt comfortable working on some of the back-end functionality to meet the functionality requirements. The more difficult task was the front-end development. Both front-end and back-end were developed separately and worked on in parallel. That way one piece is not holding up the other. Once the back-end was completely done, the integration into the front-end began. It worked well that we were able to make progress on aspects of the project that we were familiar with, while still tracking what was left to complete. This also helped in delivering incremental progress, and the progress could be quality checked throughout the project. Identify requirement gaps as soon as possible to avoid rework. There was a communication in the functionality of the code before the skeletal increment. There was a flaw in which if a player answered a question wrong, another player would not be able to answer that same question. Luckily, this bug was caught early on. If this bug had leaked through to the target increment, there would be significant more rework in the code in order to fix. Introducing quality checks and testing in your processes as soon as possible will pay dividends down the road. Dream Increment next steps. Close out graphical user interface. The last piece of development was done was implementing the animation for the wheel and making the game board more aesthetically pleasing. This was successfully completed on time. Second, conclude testing efforts to ensure high quality. To ensure all requirements are met, any edge case testing will be concluded. The animations of the GUI have been implemented. Additional testing of these features would be ideal to ensure there are no defects in these. Regression testing with these features implemented would add value by ensuring the new functionality did not break any existing functionality. And finally, cleaning up the codebase. If time permits, standardizing the codebase is good practice for client delivery. Having proper comments on each method and class would help the transition to the client and make the maintenance of the software much easier for the client. What worked and what didn't work. What worked? Assigning roles and responsibilities within the team. This included identifying strengths and weaknesses. At the beginning of the project, the first team meeting was dedicated to discussing roles and responsibilities within the team. Team members chose their desired role, and the work was divided between the roles. Assigning the responsibilities up front was necessary to fully complete tasks on time. The second thing that worked well, sticking to weekly cadence and project schedule. Another aspect of the project that worked for our team was committing to at least 1, sometimes 2, days a week to discuss deliverables. For our team, this was Monday, with the occasional Thursday if needed. Monday evenings were dedicated to review deliverables due on Tuesday, as well as brief the deliverables due for the following week. This is the meeting where we would discuss what every team member would be working on for the week. And the third thing that worked well, achieving the dream increment features. Although this was a risk for the team, the front end was able to be completed according to what we had set as goals for the dream increment. The wheel was animated on time, and the game board was incrementally updated to be aesthetically pleasing to the users. This was an aspect of the project that exceeded the team's expectations. And on to the what didn't work. Front-end development experience led to project risk. The front end was the last piece of the software that was implemented. There was slight project risk to achieve this, as the team was not very familiar with front-end development. It is difficult to estimate this task when there is a skill gap. And secondly, clearly communicating project requirements. There were slight miscommunications at the beginning of the project around project requirements. The team had to deliberate as to what we thought the requirements were and how to implement them. As a team, we needed to understand the requirements and come to an agreement on the requirements so we could implement the features how they were supposed to be designed.
We have identified 3 suggestions to next semester students. First, we suggest to plan ahead. The deadlines come quickly, so it's good to have a plan of what you need to work on and what is coming up. Second is to communicate. We suggest meeting constantly and consistently. This will ensure that everyone is on the same page. When you have a meeting, we suggest having a meeting plan. A meeting plan will keep you on track and keep meetings concise. Lastly, we suggest to review the course material. Course material should be referenced often since it can be very helpful in determining what is required and what should go into a document. We have identified 2 categories of skills that we learned in this class that can be applied to real life. First are the soft skills. Teamwork is important in this project. We had to make sure that our visions were aligned so that we were all on the same page. Time management. Especially when everyone has a busy schedule, time management is important to make sure we meet all the deadlines. Lastly is communication. We needed effective, concise communication. Next is the technical skills. None of us were proficient at front-end development, so that is something that we had to learn throughout the process. The target increment deliverable has been completed. Next is continuing work on the dream increment. We're happy to report that our delivery of the target increment is on time. And that wraps up our presentation. Thank you all for listening.